Hello, Pre-Calc. We're going to do the next section right here, and we're going to first start talking about bearings. Now, before I even start this, I'm just going to tell you that this is going to be kind of a complicated lesson, so just stick with me. My plan is, as I'm going through, to do all the examples that are on your note sheet. If you get to a point where you think, oh, I already know how to do this, or I want to skip this example, just go ahead and skip ahead. You know, if we were in class, I probably wouldn't do every single example on the board because we would run out of time. But since I have time now doing it online like this, I'm just going to do every example, and then you can decide if you think you need to do all of them. So we're going to start talking about bearings. Remember, a vector has direction and magnitude. So the direction of a vector can also be given as a bearing. Bearings are frequently given in application problems. So there's two kinds of bearings. You have a quadrant bearing and you have a true bearing. So looking at your little example there, this is east, north, west, south. Okay, so they tell you that this angle right here is 60 degrees. So for the quadrant bearing, it's the acute angle between a vector and a north-south line for the y-axis. The y-axis is the north-south line. So it's the acute angle between the vector and the north-south line. So for this example right here, the angle between this vector, and the north-south line, the angle there is 60 degrees. So the way we would write this is south 60 east, because it's south and east, and it's 60 degrees between there. That's the quadrant bearing. Okay, the true bearing is the angle measured clockwise from the north to the vector. So the true bearing of the vector to the right, we're going to start here at north, right up here, and we're going to measure from here to our vector. So we're going to measure from here to here is our true bearing. And what is that distance? Well, from here to here is 180, and if we take 180 minus 60, we get 120. So the true bearing is 120 degrees for this vector. The quadrant bearing is south 60 east. The true bearing is 120. And it says true bearings are written with 3 digits. So if the true bearing is less than 3 digits, you would put a 0 in front, like they say there. 15 degrees would be 0, 1, 5. Okay, so let's look at some examples. Example number 1. We've got our axes, and we have our vector right here, and it's telling us that this is 85 degrees, this angle right here. So it says for each vector, give the quadrant bearing and the true bearing. Well, remember that the quadrant bearing is the angle between the north-south, which is here, and the vector. So that's going to be this angle right here. What is that angle? That's going to be 90 minus 85. So that's going to be 5. This angle right there is 5 degrees. So the quadrant bearing is going to be, it's north 5 east. Okay, it's north and east, and it's 5 degrees. And the true bearing is from the north, which is right here, to the vector, So the true bearing is going to be this angle right here, which is 5 degrees, but we always use 3 digits, so we'll put 2 zeros in front of it, and that's the true bearing. Okay, let's look at number 2. Here's our axes, and our vector is right here. And it's telling us that this angle right here is 212. So our quadrant bearing is from the north-south, which is here, and the acute angle, remember it's the acute angle from north-south to here, so it's going to be this angle right here. What is this angle? How are we going to find it? Well, we know there's a couple ways we can do it. We can find this little angle by taking 212 minus 180, and we get 32, and then subtract that from 90, and we would get 58. So this is 58. So that's one way you could do it. If you knew that that 3/4 of the way around is 270, then you could subtract 212 from that, and you would get this 58. However you want to find that 58. Anyway, the acute angle is 58. We're using that angle. We're not using this angle. That's not the angle we're going to use, because even though that's between the north-south and the vector, it's not acute. We're going to use the acute angle between the north-south and the vector. So what are our degrees are 58, and what are our directions? It's south, west. And our true bearing is going to be from the north all the way clockwise. So we're going to start here, and we're going to go all the way to our vector, and that's going to be 180 plus 58, and so we get 238 for our true bearing. Okay, and then for number 3, let's do one more for practice. We've got a vector right here, and this little angle right in there is 24 degrees. So our quadrant is going to be the acute angle between the north, south, and there. So that's this little angle right there, which is 24. That's what they gave us. And our directions are north, west. And for our true, we're going to start at the north, and we're going clockwise all the way around. So we're going to take 360 minus 24, and we get 336 degrees for our true bearing. All right, that was just a little lesson in bearings. Now we're going to actually use them. All right, so stick with me, because this is a little difficult. So let's look at example number 4. Okay, remember that vectors have magnitude and direction, and so do things like velocity and force and things like that. So we're just going to write the velocity or force or whatever we're looking for here as vectors. So for this first one, an airplane is flying at a bearing of 245 degrees at 550 miles per hour. So let's draw a picture. All right, if it just gives you numbers like that, then you can assume that's a true bearing. So 245 degrees, we're gonna, for a true bearing would be from here, 180, and then to our vector over here. Okay, this blue right here is 245 degrees. And it goes at 550 miles per hour. So that's what we're using, kind of like our distance, our magnitude, I guess I should say. It's not a distance here, but our magnitude, how much. So we're going to write this as a vector. And the way that we write it, now the bearing is 245. That's how they gave it there. But when we use vectors, like anything that we've done before, we've always gone counterclockwise. So our angle that we're going to use for this vector is this angle right here. And how much is that angle? Well, that angle is, well, there's however you want to find it. This angle is this angle right here is 65. So that means this angle right here is 25. So this yellow curve that I put right there is going to be 205 because it's going to be 180 plus 25. So 205 is the angle that we're going to use, because when we're actually finding the vectors, we're always going from here this way. That's not how we do bearings. That's how we find the angles for the vectors. So our vector or velocity is going to be our magnitude, which is 550, and then cosine of our angle, and 550 sine of our angle. So if you put those things in your calculator, you get negative 498.47, negative 232.44, which makes sense where it is. It's a negative x and a negative y. So that's your answer for number 4. All right, let's look at number 5. A man pushes a lawnmower with a force of 25 pounds uphill at an angle of 40 degrees. All right, so let's draw a picture. Okay, we're gonna start right here on the horizontal, and he's pushing it uphill, and this angle is 40. And our force is 25, that's our magnitude. So to find our vector right here, we're gonna go 25. Now we always use the angle that goes from the x-axis this way, which is 40, from the problem. So we don't have to find any extra angles here. And we're going to put those into our calculator, and we'll get 19.15, 16.07. And that's our answer. And that makes sense. Positive x, positive y. It's in the first quadrant. Okay, let's look at number 6. A cruise ship is sailing at 20 knots in the direction of north 12 west. Okay, let's draw that first. Okay, where will north 12 west be? Well, here's north and here's west. Has to be acute, so it's going to be right there. Oh, it changed the color on me. And that's where our 12 is going to be. That little angle right there is 12. So the angle, and then it says at 20 knots. So that's our magnitude. And then our vector, we need this angle. We start here and go that direction. So what is that angle? 90 plus 12, 102. So we're going to say 20 cosine of 102, 20 sine of 102, and putting that into your calculator, you get negative 4.16, 19.56. Makes sense, negative x, positive y, and then in this problem it says, give it as a linear combination of unit vectors, so you would write negative 4.16i plus 19.56j. And there it is right there. That's your answer. Right, not too bad, right? Now let's go to the next page. Resultant force. If two or more forces are acting on an object, then the resultant force is the sum of the two vector forces. So we're going to do just the same thing we've done now, we've done here, except we're going to have two of them, and then we're going to add them together, just like we've added vectors together. So let's look at number 7. Two tugboats are pushing a barge. If tugboat A is traveling in the direction of south 80 east, okay, this is number 7, and tugboat B is traveling in the direction of north 65 east, and both boats are pushing with a force of 400 pounds, find the magnitude and direction of the resultant force on the barge. Okay, so this is actually, they're asking you not just for the vector, but they're asking you for the magnitude and the angle. Oh, this is hard. Okay, so we're gonna start with the picture. Let's see what's happening. Here's our north-south line. Okay, there it is. And this one we have to do a little bit differently. Here's where our barge is going, and the tugboat, the one tugboat is going southeast, so it's going this direction, okay, because this is south and this is east. It's going this direction at an angle of 80, so this is going to be our 80 degrees. This is tugboat A. Okay, this is tugboat A, and tugboat A's magnitude, it is traveling, or no, not magnitude, they're both pushing with a force of 400, so the magnitude there is 400. Then tugboat B is going north 65 east, so now it's going this direction, northeast, and this angle right here is 65. So we have to figure out, each of these are kind of like one little quadrant. This is tugboat B down here, and it also is 400. Okay, so let's start with tugboat A up here. Tugboat A, we're just gonna find the we'll call it V1. Okay, it's 400. And what is our angle that we're gonna use for tugboat A? We're gonna use this angle, because we always go from the horizontal around. So this is going to be 270 plus 80. Let me make sure I'm doing this right. Yes. So that's 350. So we're going to use 350 for tugboat A. Okay, down here for tugboat B, we're going to use, what angle are we going to use for that one? We're going to use, I didn't put the horizontal in for this one. We're going to use this angle right here, which is 90 minus 65. So we're going to use 90 minus 65 is 25. So and it's 400. Cosine 25, 400 sine 25. Okay, that is each one separately. Now, to find the resultant, we're going to add them together. And so if you do this, 400 cosine 350 plus 400 cosine 25, you should get 756.45. And if you add this together, you should get 99.59. There's your resultant vector, right? But it asked us for, the magnitude and direction, which means the angle. So the magnitude of this is easy. Remember how you find magnitude. you're just going to put this in your calculator, 756.45 squared plus 99.59 squared. Take the square root, and you get 762.98 pounds. Okay, because this is how much force. And then to find the angle, we're going to take tangent theta equals 99.59 over 756.45. And we've got to look at this before we put that into our calculator and use our inverse tangent button. We have to look at our vector and see what quadrant it's in. And since they're both positive, it's in quadrant 1. So your calculator will give you the angle that you need. Put that into your calculator. Inverse tangent of 99.59 divided by 756.45. You get 7.5 degrees. For your angle. What does that mean? It says, the problem said, find the magnitude and direction as a quadrant bearing. So let's see what that means. Here's our axes. And our angle is 7.5. So that means it's right here. And that is 7.5. So to find our quadrant bearing, we have to find this angle. So we're going to take 90 minus 7.5, and we're going to get 82.5. And our quadrant bearing, this direction here, is north 82.5 east. And that is our answer for the angle, for the direction, and this is our magnitude. All right, I understand that that is hard. This whole section is hard, but we just have to do more examples to see how it is. Okay, there are not going to be very many problems like this on a test or a quiz, but it is good practice. So let's look at the next one, number 8. One of the big things with these is you need to draw pictures. And I can help you with the pictures before you start on, like, maybe I'll give you some clues on the homework and then maybe even on a quiz or a test. Okay, 2 forces with magnitudes of 85 pounds and 120 pounds are acting on an object at angles of 35 and 140, respectively, with the positive x-axis. Okay, find the magnitude and direction of x-axis and the resultant force. So let's draw a picture. Here's our axes. All right, we've got one 35 degrees and 40, so 140. So this right here is 35 degrees, this angle, and the magnitude here is 85 pounds. And then the other one is 140. So we got to go all the way here is 140. And the magnitude of that is 120 pounds. Okay, so we got to find each one separately. So let's start with the red one. The red one is going to be 85 cosine of 35, 85 sine of 35. Okay, that's the angle that they just gave you because it's with the x-axis. So there's vector 1, and then vector 2, the yellow one over here, is going to be 120. And what is our angle going to be? Our angle is going to be 140 because that's the angle it makes with the x-axis, with the positive x-axis. Whoops, I wrote that wrong. 120 cosine of 140. Oh, I wrote that wrong. Sine of 140. Okay, there's our two our two vectors, we'll call this one vector 2, and we'll call this one vector 1. The resultant vector is going to be v1 plus v2. So you're gonna just put all that stuff in your calculator, and you should get negative 22.3 and 125.89 for your resultant vector. Now again, it's asking you for the magnitude and direction. So the magnitude is this. And that gives you 127.85 pounds. There's your magnitude. Your direction is going to be tangent theta equals 125.89 over negative 22.3. Oh, we got to look to see what quadrant this is. What quadrant is our V1 plus V2 in? It's in quadrant 2. So when you put this in your calculator, your inverse tangent of 125.89 divided by negative 22.3, you get negative 79.95. But that's not what we want. We don't want that. We want it in quadrant 2. So we're going to have to add 180 to that to get our real angle, and that's going to be 100.05 degrees. And that is the angle that it makes with the x-axis. That is, it's in quadrant 2. That's this angle right here. And that's what it's asking you for. And the direction to the positive x-axis of the resultant force. The one before it asked us for the quadrant bearing, so we had to rewrite our angle. This one asks us for the angle with the x-axis. There's our direction, and here's our magnitude of the result. Okay, let's look at number 9. Two cranes are lifting a statue. Crane A is pulling with a force of 600 pounds at an angle of 35 degrees to the left of the statue. Crane B is pulling with a force of 750 at an angle of 50 degrees to the right of the statue. All right, so let's draw our picture. Here's our statue, and here's our horizontal. So crane A is pulling with a force of 600 with an angle of 35 degrees to the left. So this is 35 degrees to the left with a force of 600. And crane B is pulling with a force of 750 with 50 degrees and 750. So we've got to find each one separately. Let's start with the blue one. We'll call it V1. That's going to be 600 cosine of what? What's our angle going to be? Our angle has to go from here to here. So that's going to be 90 plus 35, which gives us our crane B, or our yellow one here, is 750. And what's our angle? Our angle is from here to here. So that's going to be 90 minus 50. So that's going to be 40. And our resultant, we're going to add them together. And if you do that, you should get 230.39 and 973.58. Find the magnitude. I'm not going to write it all out. You know the formula by now. The magnitude I get here is 1,000 1,047 pounds. To find our angle, we're going to take tangent theta equals 973.58 over 230.39. And what quadrant is this in? This is in quadrant 1. So you can just get your angle that it gives you of 76.69 degrees. All right, so what did it ask us? It said, and the direction with respect to the horizontal. So that's what that is. This is the direction with respect to the horizontal, or the x-axis. The other one called it that. So there's our direction, and here is our magnitude. Okay, I'm going to stop this video right now and finish this, these notes in another video so it doesn't get too long or too overwhelming.